Well, hello out there in remote learning land. Today's hot topic is the coordinate system on Earth, right? Commonly called latitude longitude. Um, so we're going to crank through that and talk about why it's so important for us in everyday life. Uh, and that's our goal for today. Hopefully you cranked hard on those do now questions. Let's do it. Okay. This is a childhood game you're probably all familiar with, right? A little Battleship. And can you sink my battleship? Well, Milton Bradley, the company that set this up, was actually trying to teach young kids a coordinate system. They put letters across the top and numbers down the side, and you had to, of course, figure out where the person's ship was. Well, Battleship is this guy here, so I'm going to fire a shot to B4, and there it is, right? And then you keep going, right? C4, D4, and E4, and finally, boom, we have sunk that battleship. Adios. All right. Well, I'm going to switch it up a little bit. Right now, we're going to go for the cruiser. But look at the sides here. It's no longer just letters and numbers. Now it's actually got numbers, degrees, and a direction. Well, if you take a look, the ones going this way in the 40s, those are latitude lines. The ones coming this way, right up and down, those are longitude lines. So it works the same way. It's just a little more detail. Let's sink the cruiser. That's this guy. So here we go. You start with latitude. Well, that's 45 degrees north and 78 degrees west. All right. Keep going. It's still 45 north, 79 west. And one more, 45 north latitude and 80 west longitude. And adios, you've sunk the cruiser. And that's basically how the grid system works. Of course, we can get a little more in detail, but you have a vertical and a horizontal component. All right, how do we describe a coordinate system? Make sure you get this in your notes, right? A grid of imaginary lines to locate any position on Earth. No 2 points can have the same coordinates, so it had to be a system where there was no overlap at all. All right, and of course you go by directions, right? You know the compass, north, south, west, east. But in between, you get more detailed, right? So this would be northwest, northeast, right? Southeast, southwest. And as a navigator, you get even more detail. If you're in between here, you would say north by northeast. Over here, you would say east by northeast, right? It would be more specific. And then to pinpoint it, well, there's 360 degrees in a circle, so you would give it a number of degrees. Okay? All right. Read this through, right? How do we define latitude lines? They are parallel, right? Sometimes they're just called parallels. Make sure you read all that through. Okay? Distance in degrees, it's north or south of the equator. The equator is the reference line for latitude. That's 0 degrees. They never ever touch. They never cross their parallel, right? The equator separates north and south. But what's confusing to some students, while the lines run east to west, we label them north to south. Because if you're crossing latitude lines, you're either going north or south. Okay? They measure from 90 north to 90 south. If you have something like 91, you're making a mistake. It's got to be between 90 north and 90 south. Okay? That's what it looks like from the North Pole. And that's from the equator view. Okay? Can you name these lines of latitude, right? Famous lines? I'll bet you could name most of them. We'll start out with the easy one, right? The equator, of course, right in the middle there. All right? And then there are some other ones. I'm sure you've heard of these. Let's make sure you know where they go. So your good old North Pole, of course you know that, followed by your South Pole. But what about these others, the tropics and the Arctics? Where are they? Well, the Tropic of Cancer is in the northern hemisphere, 23.5 degrees north. And the Tropic of Capricorn is in the southern hemisphere. I know these names probably look familiar if you know your zodiac signs out there. This has to do, of course, with the position of the sun at different times of the year. And yes, that does relate to the zodiac as well. Okay? And, of course, the Arctic and Antarctic Circle. So, Arctic Circle up here and Antarctic down there. Now, we're currently heading towards winter, right? We're in fall now. We're heading towards winter. The sun is getting lower in the sky. The days are getting shorter. Well, that's because the Earth is tilted. And the concentrated rays of the sun are going to be more in the southern hemisphere at this point. And that's why our days in the north will get shorter and the temperatures will start getting cooler. All right. Label the following points. What is ABC? Hit pause. Try to do this on your own. Okay. All right, let's check how you did. So for the first one there, A looks like it's on 30 degrees north, right? B certainly looks like it's on 60 south. And C, of course, somewhere in the middle there. So you approximate about 15 degrees north. Which 2 points are on the same latitude? Well, you got to be on the same latitude line. And the only ones that are there are, of course, A and E. All right. So then we jump to longitude. Make sure you read this through. Now these lines are going this way, of course. They're not parallel. They converge at the poles, right? There's a polar view. They actually touch at the poles. So there it is. They measure east to west. We draw them, however, north to south. Their nickname is called meridians, and of course the prime meridian is the main reference line for lines of longitude. Okay? Labeling them east or west. We are in Elmont, are in the west, right? We're about, a little over 70 degrees west. If you head towards, across the Atlantic, you get to England. The prime meridian cuts right through Greenwich, England. And then if you keep going, you're in the east. Okay? This time we're not going just to 90. Now they go to 180. So make sure you're not mixing those two ranges up. Okay? They're spaced 15 degrees apart on a globe, and that's because every time zone is another 15 degrees. But if you're zoomed in on a map, well, then the longitude lines are going to be closer together. Okay? They'll be every degree. But on a globe, they're 15 degrees apart. That has to do with the Earth's rotation at 15 degrees per hour. We'll talk more about that later. But every 15 degrees is a new time zone. Okay. So let's get the labeling down, right? Your prime meridian in the middle. If I go to the west, time gets less, they say. Not a proper word, but you get the gist. So I'm getting earlier, right? If I go to California, I get earlier. If I go east, time increased. So if I go to England, it gets later. Okay. So here we go, 15, 30, 45, 60. Notice they're every 15 degrees. Those are time zones. And this would be, 1 hour earlier, 2 hour earlier, 3 hour earlier, etc. Going the other way, same thing, 15, 30, 45, 60. And again, this is an hour later, 2 hours later, 3 hours later, etc. The international date line, that's not a number that you call when you're lonely on a Friday night. I joke. This is the actual place, the opposite side of the world from the prime meridian. And you'll notice it's a little bent. That's not a mistake. They try to bend around countries so they don't cut through the middle of it. This way, one country isn't in one day and the other in the next day, right? It would be split by a time zone. So for the little countries, they do that. For the big countries, there's nothing you can do, right? Like the United States, we have 4 different time zones. We're so big. You can't wrap a longitude line around that to put everybody in the same time zone. That doesn't make any sense. But on the opposite side of the world there, you'll see the directions look switched. You're not seeing backwards. That's how it is. If you think about it, that's the perspective when looking at the Earth. All right? Okay. So label the points. A looks like it's right there. Actually, I should take a second, right? Hit pause, figure it out yourself. Okay. A is right here, so hopefully you said 30 degrees west. B is over here in between 30 and 60, so hopefully you said something like 45-ish, right? Obviously you can get more accurate with a protractor, but 45 degrees west. And C, of course, you're looking at about 30 degrees east. Which two are on the same longitude line? Well, you tell me. Which two are on the same line? Hopefully you said these two here. It also means they're on the same time of day. Okay? So, yep, points D and E are both on the prime meridian. All right. Here's a little summary map. Please fill this in. We'll go through these, of course, in the lesson when we're going through it. Okay. And a couple of summary questions. So for the first one here, it wants to know which diagram is correct. Some students get confused, but remember the longitude lines converge at the poles while the latitudes are parallel. So you got to go with this guy here. And what is the coordinates of point A? Well, it's in the southern hemisphere. So you're at 0, 10, 20, halfway, about 15 degrees south. And going this way is toward the east, so that's 15, 30 degrees east. So you're looking at, of course, choice 4. All right. Hopefully you were following that. If you got to watch it again, right? Go back, take the notes, bring your questions to the GC. I'll meet you over there.